Hello and welcome to the Sikuliaq. We are here in the Arctic. I'm standing with Dr. Jim Thomson, an oceanographer from the University of Washington. And he's going to talk to you today about his research up here in the Arctic and what it's like to be on a ship up here in the north. Please be patient with us. We are streaming this through satellite. 4G has not made it this far north, so the video may cut out or stop altogether. We will do our best to get reconnected with you as soon as possible. Also, please feel free to use the chat feature in YouTube to ask questions.
Are we back?
All right, really sorry for the delay there, guys. Our satellite connection did go down, which is one of the risks of doing this up here in the Arctic. We did record the things that we were just talking about, and we will post them right. They'll probably be available tomorrow for you to view. But I'm going to send it back over to Jim,
Sure.
and he's going to kind of keep rolling with what we're talking about. Please do send your questions over to chat, and hopefully we'll stay live this time.
Yeah. I would say that's a great indication of what it's like doing science in the field, that the conditions are always changing, things are always happening, and you take the tools you have and you do the best you can to roll with it. So I would also say that for those of you young folks out there, if you ever complain to your parents about your internet connection, boy, you don't belong up here. It comes and goes all the time, and sometimes we have internet and sometimes we don't, but even when we have it, it's a very, very slow connection. But let me tell you a little bit more about what we're doing up here. First, just to recap, we're north of Alaska in the Arctic, and we're studying how the Arctic freezes up again in the fall. So every summer the Arctic melts out because the sun's up, and then in the fall the Arctic goes to dark. It goes completely dark. That's one of the defining features of the Arctic. And so when it's really dark, it gets really cold, and the surface of the ocean freezes, everything freezes. So right now, you can see on our real-time display on board the ship, we've got an air temp that's about minus 14 centigrade, so that's about 6 Fahrenheit. The wind's up, so actually when you go out on deck and do some work, the wind chill's probably about minus 10 Fahrenheit. So it's certainly chilly. It's certainly, we don't spend more than a few hours out on deck, even all dressed for it, before we rotate people out, make sure no one's getting frostbite or too cold. And that's just what's happening in the Arctic right now. It's cold. It's getting dark. There's only a few hours of daylight today, and we're trying to make the best use of that daylight for a few critical measurements and things that we need to do for those measurements that need daylight. And then the rest of the work we'll do in the dark. And we work in the dark all the time. This ship is running 24 hours a day. There's a lot of work to be done, and so we make sure that we're maximizing our time up here, and we're always have somebody from the science team working. It's a big team. We've got 26 scientists on board. There are about another 20 ship's crew that are running the ship, doing everything from driving the ship to maintaining the engines to working in the galley and cooking food for us. There's a big team on board that's making it happen, and there's always something going on board the ship, even in the middle of the night. Someone's up and they're working, and that's how we get the most done when we're up here. So what we're doing right now is we're headed to pick up a mooring. The mooring's been out for about 4 months, and it's been measuring the temperature of the Arctic Ocean, and it's been measuring the waves in the Arctic Ocean. And we know from our other measurements that both of those signals are increasing. It's getting warmer, and the waves are getting bigger. And all that's really related to the sea ice, which is a big part of what we're up here for. The relationship is that if the ocean's warmer, the sea ice doesn't form, and if the sea ice is gone, then there's a big ocean that can have waves. And that open water distance of no ice, that's what really controls how big the waves are. And so that's what we're seeing in the last few years, the last few decades really, is a warming Arctic Ocean, less sea ice, and more waves. So we're trying to understand what that means for the whole Arctic system. We're trying to do it at multiple places around the Arctic, so we're going to one of those stations now. We'll get the mooring back and we'll get the data out of the mooring. Here we are, that's the ship. we're en route to this mooring station. We'll be there in about 13 minutes. And there'll be some time to set up and get ready for all the activities when we get there. If it goes well, the mooring will be at the surface in maybe about 20 minutes after we get there, and then we'll pull it back onto the ship and get all that data off. If it doesn't go well, it's going to take a little longer, and that's exactly what happened to us yesterday. Not everything always goes to plan, so the moorings, what they're trying to do is they're trying to hide out underneath the sea ice and make their measurements. So we put them below the surface, and if you came and drove a boat to that part of the ocean, even in the summer when the sea ice is not there, you wouldn't see anything. They're hiding there so that when the sea ice comes through, it doesn't damage the mooring. So we get that temperature data, we get that wave data, only if we get it back from the seafloor. And to do that, we have a messenger line that's hiding down there with it, and when we send it a signal with a sonar, it will open a lever and send that messenger float to the surface, and that's what we'll grab onto. So yesterday we did 3 moorings, and 2 of them came right up when we sent the signal, and 1 of them did not. So the one that did not, we went fishing for it. And we took literally a big hook, a very big hook, and put it off the back of the ship, and we towed it around, and we got lucky. We hooked it, we got the whole thing back, we got all the data back, and everyone on board was really excited, and we spent the night probably staying up too late and working on all the data. But it was really worth it, and nice to see the data. So we're hoping for a similar thing to be happening here, and hoping to get that data back. You can see there's a lot of other stuff going on here. There's all these different live displays. They're showing us everything that's happening on board the ship, and that's again because the ship is never idle. There's always a lot to do on board the ship. And everyone is rotating through and having their meals, and then there's everyone has these small rooms where we have 2 bunks to a room, and at any given time, some people are in their bunks sleeping, and some people are out on deck doing the work, and we're just rotating and rotating through. So right now we're in just a little bit of sea ice, and so that's going to be another factor when we get to the mooring. That mooring won't make it to the surface unless we can get through that ice. And so in this case, we'll have the ship make a little hole in the sea ice. We know right where the mooring is, and then we'll try to get the mooring to come up within that hole and get that data back. Now, you might be wondering, well, if all these measurements are just below the sea ice, how do you know what's happening right at the surface? How do you know what's happening right at the sea ice? And particularly for this trip, this project, we're really trying to understand how the sea ice advances in the fall. Now that it's cold and dark up here, how does the sea ice get formed for the winter ice cover before it goes away again next summer? And so to do that, we need different tools. We need tools that are right at the surface. We also need tools that are not right next to the ship, because as the ship goes through, by definition, an icebreaker breaks some ice. Not a lot. I mean, we're pretty small compared to the huge Arctic Ocean that we're in. But we do make a little bit of disturbance. And we don't want to measure that disturbance. We want to measure what the actual Arctic's doing. So to do that, one of the tools we use are buoys that we put out away from the ship and let them drift away from the ship so they make a nice undisturbed measurement. We really understand just what the natural environment's doing. So I'd like to show you one of those. This buoy is something that we make at the University of Washington. We build this ourselves. And you can think of our lab in some ways as a big makerspace. For those of you who are into robotics and are working with Raspberry Pis and Arduinos and those kind of things, that's exactly what's inside here and the kind of work that we're doing with these. So you might be able to build one of these yourself. This floats, so this part, the yellow part, is like a life jacket. It's like a big flotation collar for it. When it sits in the water's about here. This part is below the surface, and this part is all above the surface. And so that's right where the action is. If you want to study how sea ice is formed, the sea ice is going to form at the surface. That's because the ice is buoyant. And you know that. You put ice in a glass and then fill it up with water or juice or soda or something. The ice floats at the top, right? That's where the ice forms. That's also where the conditions are the coldest in the Arctic, is right at the ocean surface. And so we get the ice forming around here and then the ocean at some distance below. So these drift around and they make all sorts of measurements trying to understand that whole process. And you have to measure a lot of different things to get that right. You have to know what the air is doing above, and you have to know what the ocean is doing below. So key thing again is temperature. We're always measuring temperature and trying to understand the temperature exchanges. So we measure the air temps up here and we measure the water temps down here, and that's a big part of how sea ice is formed. If the air is really cold and the ocean's warm, then the ocean will give its heat to the atmosphere. It'll lose heat to the atmosphere, and it'll keep losing heat to the atmosphere until that ocean gets to the freezing temperature. Now the freezing temperature for salt water is a little bit different than the freezing temperature for fresh water, but not much, a few degrees C. So at about minus 1.8, that ocean will not lose any more heat. Well, it will lose more heat. It won't drop its temperature anymore. Any additional heat loss makes ice. So what we're seeing right now outside is rapid ice formation, and it looks really dramatic, like it's happening all at once overnight. And in terms of the ice, it is happening overnight. But it's part of this much longer story that's been happening for the last month. For the last month, the ocean's been losing all of its heat to a cold atmosphere. It's been steadily giving off heat. So there's a lot that's been happening that hasn't been as obvious this whole month. And then today, where we are right now, is the magic day where we hit the freezing point and now the ice comes, and it comes fast. So that's the kind of thing we're trying to measure with this, is have this out long enough to see all of that. We measure a bunch of other things also. We measure the wind, and we measure the waves, and we measure the turbulence too, to understand just the details of how that is mixing. It sounds like we have a question online.
Yeah, how do you get those back once you've deployed them?
That's a great point. We do track them, and we usually recover them. There's all this raw data on here we want, but we also have engineered some, we call it telemetry, to send the data back. So there's a satellite modem in here, and it takes some of the measurements, just a little bit of them, because the satellite modems are very slow, and we take the best data and we send that back through the satellites, and we get that to our server on land and store the data. But we do also get them back. So we track them. They have radio collars that we use for tracking them. And then when we come to get them back, we have the ship pull up alongside them, and we try to reach them. But the ship is tall, and you can't just reach over the side of a big ship and grab something. That wouldn't be safe, nor are your arms long enough. So we have these big, long poles, and we hook in anywhere in here. And so this is designed to be a nice, big, wide target, a grab ring where you can grab it anywhere and you can just pull it, and that's all fine to grab onto and pull. We also usually trail a long string with some floats behind, and that's a bigger target to grab. So, and that part's pretty fun. People like to kind of compete for who can get it the fastest and who can get it on the first shot, that kind of thing. So we do try to have some fun while we're out here. While we're working, we try to, I don't know, take time to enjoy the little parts. Another question online.
Yeah, somebody online is wondering what temperature does seawater freeze?
It's about minus 1.8 centigrade. So in Fahrenheit, that's maybe 28 or so, 28 degrees Fahrenheit. So it's really not that different, actually. But it's the salt in the water that changes it. And it's actually a strong relationship with salt, a function of the salt. So if it's fresh, 0 degrees C, 32 Fahrenheit, right? And as it gets saltier and saltier, that takes that freezing point down further and further and further. So you could even do this in an experiment at home. You could take 2 ice trays in your freezer at home, and you could fill one with fresh water, and you could fill one with salt water, and then you could put them in the freezer for an hour, and then check on them, and then check on them an hour later, and see. And you should see that the salt is taking longer to freeze. But you don't have to trust me. Try it yourself. Okay, so that's these buoys. I want to show you a couple pictures of the work we've been doing also. So we've been taking a lot of pictures. A lot of that we can't send back because the satellite link isn't very strong, but we have some pictures of what's been going on. So there are some pictures of us out on deck working. You can see we're really geared up when we're out on deck working. We've got all these big suits on. Everyone has hard hats on. We've got a lot of safety gear. And so here we're bringing in a mooring, and we've got all these people help bring in a mooring. And you might think, well, why don't you get a winch to bring in the mooring? Why do you have all these people pulling on the line? Well, we do have a winch. The winch is over here, but we're having the people help keep the line off the deck because there are instruments that we don't want to damage as they come in. And so we're having the people bring a bit of line in and then clear off the instruments and then bring the next bit of line. And that's a tricky operation. So a lot of what we're doing on deck is a lot of slow coordination. And this looks like a lot of action, and it is a lot of action. But boy, leading up to this, there's a lot of careful prep. There's a lot of time sitting and talking and making sure everyone understands what we're doing and making sure that all these people are moving in a really coordinated way. So the other thing is to show you some ice. So we've seen a bunch of different ice that we've been through, and this for me is my favorite type of ice. It's a kind of a fun name. This is called pancake ice. They look like pancakes, right? And that is the technical term for this type of ice. It's just pancakes. They're kind of funny shaped pancakes. They're not always perfectly round. In some cases they can be fully round. We have another picture later where they are perfectly round. Sorry if I scroll really quickly here. You can see these are little pancakes, little round pancakes, and these were a day later when we were coming to this mooring. So this is what the mooring should be looking like today when we go for this mooring, with all these little pancakes everywhere. And this is a really specific type of ice that only forms when there are waves present. And so if there are no waves, you get just a smooth sheet of ice. And many of you may have seen this on a lake or on a pond if you live in a cold region. And when it freezes, it's just one big solid piece of ice and then you can go play hockey, right? Well, here in the Arctic Ocean, if it's moving, you can't make a solid sheet of ice because it's always moving. And so what forms instead are these little pieces of pancake. And one of the things that I think is really cool about these is that the size of the pancake corresponds to the waves themselves. If they're big, long waves, then you get big, long pancakes. And if they're short, little waves, you get small, little pancakes. So that's where these things are really tightly coupled together. You really can't study one without studying the other. If I want to know what the ice is doing, I need to know about the waves. And if I want to know what the waves are doing, I need to know about the ice. I'm going to go back and show you a couple things about the ship because people are probably interested in what the ship looks like. So this is us working on the ship. This is us trying to get that mooring. The ship itself is pretty big. That's a look at the full ship. This is when we're in the port of Nome where we loaded up and the ship came here from another project and we met it here and all the scientists got on board here and we had all of our gear was already loaded on board the ship. And so no sea ice in this picture because it's not cold enough there in Nome, Alaska yet. It will eventually be. And then we headed out from there. And you can see the ship has got a big, strong steel hull. It's meant to be able to go through the ice. There are a lot of technical details about that. It's not truly a big icebreaker. It's not a heavy icebreaker. It's a polar class 5 boat. And that means it can go through the kind of new ice that we see right now. When we're in the fall and the ice is just forming, and the ice is maybe 10 centimeters, 6 inches thick, something like that, up to about a half meter, those kind of thicknesses, then that's sea ice that this ship is really well suited to. So it's kind of perfect for this project we're doing right now because we want to be in that new ice and understand how that new ice forms. So here is on our way out. It was pretty rough. You can see a lot of wind and waves out there, and so there's big spray as the ship pounds into the waves, and you can already tell, there's a hint in this picture that it's getting cold. There's some ice forming on the side of the ship here, and that's telling you that the air is really cold, right? Any water that comes up and lands on the ship with the spray is immediately freezing because the air's so cold. And so that's similar to what's going to happen at the surface of the whole ocean here in this region soon and across the whole Arctic. The air is going to be cold enough that it pulls all that heat out of the ocean and it all turns to ice. But exactly how it does, those details, that's what we're after. There are a lot of other people on the boat. There are the officers who are driving the ship, and we spend some time up on the bridge where all of that is happening, and we are always up there talking to the officers running the ship and saying, okay, here's what we're planning to do next. Let's make sure we coordinate that, and we'd like to go over here now and do that. So there's a lot of collaboration working together with the officers on the ship and the engineers who run the ship and making sure that we're doing everything in sync together. And then when we're down on the deck, there's a lot of coordination too. So in this picture, I'm in the middle of the picture and I'm talking to everybody about what we want to do next, and then there's some of the ship's crew and technical staff are here helping us do everything, and then some of the people that the other scientists are on board and helping with all this. So we're all constantly working together, and that's a big part of what it takes to get all this science done and make all these measurements is this big team. Okay, I'm going to wrap up. I just heard a call on the radio that we're very close to this station, so I want to leave you with a really nice parting shot about how beautiful it is here. It can be very cold and kind of gray and dark, and it's not for everyone, but it also can be really beautiful. So I personally really enjoy being up here. It's a lot of fun to get to be in this unique environment, and occasionally we get days and shots like this. So I'll need to be on deck soon, and I'll just answer a couple questions, and then you can see some of the gear that I'm going to load up on to get out there in the -10 Fahrenheit wind chill. What's happening online?
Yeah, we have a couple questions online. What is the average speed of the ship when we're underway?
That's a great question. The ship usually goes about 10 knots, so that's maybe 12 miles per hour, but we're on a nautical environment. We use knots. That's in open water. That's when we're steady ahead. When we're in the ice, we end up slowing down. That's in part for safety. That's also because the engines only have enough power to push the ice aside so much. So last night we were in some heavier ice and we were doing about 3 knots or 4 knots. So it really varies depending on how much ice we're in. And you can always tell when we're in the ice, because anywhere on the ship you can hear it. You can really hear it. It's just rattling and making all this noise. You can think of the ship as one big steel drum, and the ice is just banging along the side of the drum. And so you get used to it after a while, and then you can sleep. But the first few times, boy, you really have a hard time sleeping. People wear earplugs, they figure it out, but it's pretty loud.
Great. Another question, how many other ships are up here doing this kind of work, and what countries are they from?
That's a great question. Right now, there's almost nobody else up here. We're very late in the year, and one of the reasons we're up here so late in the year is that the ice comes very late in the recent years. Part of the warming and the climate change that's going on means that the ice appears a lot later. So in my career, I haven't been up here in November before because the ice was already solid and formed, and the things we're trying to study had already happened. They'd happened in October, and that's when I was up here before. So the fact that we're up here now is part of the signal of that climate change, but almost all the other research vessels have gone home. In the U.S., we have a heavy icebreaker run by the Coast Guard. That's called the Healy. The Healy's already tied up at the dock in Seattle, and it's tied up for the winter. Some of the other icebreakers that we commonly see up here are icebreakers from the Canadians, and we often do coordinated operations with them. They're mostly gone for the year. We also see the Korean icebreaker Aeron up here. They're done for the year already. The Japanese icebreaker, the Aeron, they're also gone. Swedish icebreaker, the Odin, also gone. So I think the other boat that's out right now is over in the Eastern Arctic. There's a big project that a lot of our colleagues are on right now called Mosaic, and that has a German icebreaker, the Polar Stern, who's going to spend the entire season in the ice, and they're overwinter in the ice and drift with the sea ice. It's a really landmark project that's going on right now. It's on the other side of the Arctic. And that's probably one of the only other research vessels operating up here right now this late in the year. But I'm excited that we get to be here. This has been 5 years in the making, planning this, to be here right now and to capture this. And we're seeing it all unfold before us. If you pan over here this is the view from the masthead of the ship right now. We're looking at how much ice we're in, and so you can see we're coming into, this is all new, thin ice. And we're getting to this mooring station, and this is what we're here for, is to see this process unfolding right now. So we're going to get some of the data back that's already been recorded on this mooring, hopefully, if it goes well, and we're going to try to get more instruments out and measure this as we go and roll with it from there.
Great. We're going to take one last question,
Okay.
And then Jim is going to head out on deck. So the last question is, how long does it take to build one of those swift buoys?
That's a good question. I'd say these days we're getting a lot faster at it. Maybe it's a full, steady week of work, maybe about 40 hours of work. Hidden inside here, and you could maybe find some pictures on our website, are 3 boards of electronics, a little single board computer, and then modem, power controllers, voltage regulators, all those kind of things. And the electronics is one of the big things. The rest of the hull is aluminum, and it's been machined and then anodized. So that machining takes a while. We have a really nice machine shop, so we're pretty fast at it compared to maybe if you tried to do it in a smaller shop. And then there's always lots of little details and things, and it's faster now because we've done all the work to get these sensors from the different manufacturers and have them all integrated so we know how they work, and they know they'll plug right in and work with our software. And starting that up, that's months and months of work. But now that we know how to do it, now that we've got our routine down, it's quite a bit faster. But yeah, there's a lot of software that goes into this. There's a lot of electronics and hardware and kind of robotic style stuff. And then there's some of the more just machining. There are a lot of people involved in making this, a lot of different roles for people to play that contribute to this. Okay, so I need to be out on deck soon, so let me give you a feel for what that looks like. So again, today wind chill is probably about -10 Fahrenheit, pretty cold, but I know that I'm only going to be out on deck for probably about an hour to do this, and if I'm really getting cold, I can call for another scientist to come and give me a quick break, and I'll run in, get a cup of coffee, and warm up. So this isn't quite the as extensive as you might guess, but it's still enough to keep me warm for about an hour out on deck. So I already got a vest on. I'm going to just go for some more layers here. One of the things I love the most are these little buff things that probably make it hard for the mic to work. But what I'm going to do when I get out there is pull this all the way up and cover my face and my ears and everything with that. Want a good couple fleece layers. These are good because they're not too bulky. Sometimes if it's really, really cold, I wear a down parka underneath my outer coat, but then I'm sort of like Michelin man. I have trouble walking around. I'd say my favorite thing are these big overalls because they're really warm, but most importantly, they have flotation built into them. So the biggest risk with something bad that would happen safety-wise out on deck is falling in.
So falling into freezing water would be terrible. There's definitely, the hypothermia will set in quickly, but there's also just staying afloat in a lot of heavy gear. So these pants have flotation built into them. So will my jacket that I'll put on in a second. And that's a really a key thing for both for warmth and for safety. So I'm going to pop off the boots that I was wearing around inside the lab here and get these on and get some deck boots on. I've got really thick socks on already. And the deck boots that I'm going to put on, these have steel toes, so just in case anything drops on me on deck, I'm covered there. They're pretty thick. They're very waterproof. They're great, so they'll help me out a lot. Kind of button up all the side spots here so there's no cold air leaking in, because boy, you feel it the minute you go out there. If there's any spot where the cold air can get, it'll be there, it'll find it. Yeah, these are definitely my favorite. The other thing I love about these is there's some fuzzy pockets right here. Oh, these pockets are great. Okay, so and then the jacket's the thing that goes on outside, and this jacket is, I think of this as, you know, my little life support system. I've got all sorts of things that just live in here. I've got a personal rescue beacon in here, so if I fell in the water, I could light this off and people would know where I was and come find me. I've got a whistle. If I fell in the water, people could come find me. I've got a bunch of little tools that I just carry around all the time. I've always got a knife on me. I've always got a couple knives on me, just in case there's a line that's caught somewhere. Always got a headlamp because there's not much daylight out here. Knife, a few things like that. Tape, always got tape just in case, you know, something needs to be attached or, you know, just kind of temporarily rigged up. Other side of the jacket, I've got a strobe light that'll activate in water, so if I were to fall in, then I'd be immediately visible. Again, it's dark, so that's probably the best bet for the ship to find me. Other pocket actually has another different type of beacon with a different radio frequency, so, and also water activated, so if I fell in, the ship up on whoever's on watch on the bridge would immediately get an alert that this was in the water and that I was in the water, and they'd be able to chase me down. So really trying to take that very seriously and be very careful about that. So this coat also has all that good flotation built in, so I am definitely would bob like a cork if I fell in, but I'm not inclined to try it. And then, okay, a good hat. And again, I'm going to tuck this all up when I get out there. That buff is going to really round that all out, and I'll be just about that much skin showing, including just some glasses, or if it's really bad, I wear goggles sometimes, clear goggles. Don't want the ski goggles. The regular ski goggles would be too dark because there's no light out here. Got to have a hard hat on because we'll be running winches and cranes and things, so that's just another, you know, standard safety thing. And the wind's so strong that I always go for one with a chin strap, more like a climbing helmet, because you can just get blown off at any time. And then a good set of gloves. These ones I really like because they're very waterproof, so when I'm, you know, handling wet gear and whatnot, they're good. Nice long cuffs, and make sure that they're over there. If it's getting really cold, then I'll go for the mittens, but with the mittens, it's hard to work, you know. So, I think I'm pretty well geared up. I just heard the phone ring, which was probably the bridge officer calling down and saying it's time to go get that mooring. So we're on station. I can feel the ship is stopped. I can see from the plotter that we're right on that mark, and we're ready to roll. So thanks everyone for tuning in. Sorry about the connection, but that's how it goes up here, and hopefully we can push the other part of the video up to you, and you can take a look at it later on. I'm done. All right.
Thank you guys so much for joining us. There were some other great questions that we didn't get to. We will have another live stream next week, actually 2 of them. One through the Explore by the Seat of Your Pants organization for any classrooms, and a second one for the general public. So head to iceinmotion.com for the details there, and we hope to see you there. Thanks so much.